Section 16.3 Supporting Information. Pi network in 135 hexatriene and other polyions. Now let's look at the pi-type orbitals of 135 hexatriene. There are 6 carbon atoms. Each carbon contributes 1 2p orbital and 1 2p electron. So from the 6 AOs, we can make 6 MOs. All 6 MOs are pi-type MOs. If we look at this one, there are 0 nodes, 1 node, 2 nodes, 3 nodes, 4 nodes, 5 nodes. As the number of nodes increases, the energy of the MO increases. We have 6 2p electrons. They become 6 pi electrons. They occupy the first 3 lowest energy MOs. Therefore, this is the highest occupied MO or HOMO, and this is LUMO, the lowest unoccupied MO. And we can approximately treat this as a particle in the box problem. We just have 6 particles inside this one-dimensional box. So what's the quantum number for HOMO? There are 6 pi electrons, therefore the quantum number for HOMO is 3. The quantum number for LUMO is thus 4. Okay, so now let's look at hexatriene. We have the experimental data for its longest lambda. It happens to be lambda max in this case. There are 6 carbon atoms. The quantum number for HOMO is 3. What's the carbon chain length? It's roughly 1.4 times 5 because there are 5 carbon-carbon bonds in this molecule. Okay, 1, 2, 3, 4, 5. 5 carbon bonds. Now we look at some other similar polyions. Let's say butadiene, we have 4 carbons, and HOMO is 2, and LUMO is 3. We have the carbon chain length 1.4 times 3. Octatetraene, we have 8 carbon atoms. The N-HOMO is 4, and then we also have carbon chain length here. Right? So what you can do is you can again use this equation. Hc over lambda is the equation for the energy of a photon, and the energy of the photon absorbed by this molecule is equal to the energy difference between HOMO and LUMO. So over here, LUMO is N-HOMO plus 1. Therefore, you need to use N-HOMO plus 1 squared minus N-HOMO squared. That's 2 times N-HOMO plus 1. On the bottom, you need the chain length squared. So by looking at these formulas, you can see the chain length is simply 2 times N-HOMO minus 1. Now you have 2 N-HOMO plus 1 on top. You have 2 N-HOMO minus 1 squared on the bottom. That means the larger the N-HOMO, the smaller the energy of the photon. This is the so-called redshift phenomena in quantum mechanics. All right? And then again, when we have a larger N-HOMO, we have a smaller photon energy, therefore longer wavelengths. This is the so-called redshift.